All right, so we've Hogsmeade, which is a small town, and residents often plant flowers in their front yard, which we know contributes to the positive atmosphere in the town. I love flowers, and so do most people. So we have a supply and a demand system for dozens of flowers. So these are just generic flowers. And so that one unit is a dozen. So we're talking about sort of bundles of flowers together. Okay, so we have our supply and demand system, which for this question is also going to be, it's going to be relevant that this is our marginal benefit and marginal cost. Okay, so we're first going to find the market equilibrium. So we have a study showing that the impact on the well-being of the community is 10 galleons per dozen flowers planted. So when the quantity goes up, we have a 10 galleon positive externality on the community. Okay, so we're first going to go through and solve for the market, and then we're going to find the deadweight loss. Okay, so this gives us the market failure. All right, so we have price on the vertical, quantity on the horizontal, and then let's do the rest of this problem. All right, so we have our demand curve, which is this thing. So vertical intercept of 100, and then kind of runs off. And then we'll call this the demand curve, which is also our marginal benefit curve. And then we have a supply curve. And we'll do this in green. We have upward sloping. We know this runs through the origin. So this is our supply curve, which in this case is our marginal cost curve, or it's always the marginal cost curve, but in this case, it's the marginal social cost curve. Okay, so here's our system. And then what we're going to do is first solve for the market. So as always, the market solves by setting the marginal cost equal to the marginal benefit. And we'll just set this up like this. So the market, we have marginal cost equal to marginal benefit. And we just solve for the thing. So this is, the marginal benefit comes from the demand curve. So this is 100 minus 1/2 Q. And then the marginal cost comes from the supply curve. So that's just a nice simple Q. Okay, so then we just solve for Q. So this is 3/2 Q is equal to 100. And then we get Q is equal to 200 over 3. We'll call this Q hat. We know there are externalities, and we know the market does not solve for the socially efficient quantity when there are externalities. We denote the socially efficient quantity with a Q star. So when the market doesn't give us Q star, we denote this with a Q hat. So our Q hat is equal to 200 over 3. And then our price, just coming from the supply curve, price is also 200 over 3. So our P hat is equal to 200 over 3. All right, nice. The second part of solving for the market failure, so we solved for the market solution, but we also need to solve for the deadweight loss. And to get that requires thinking about externalities. So we know there's a 10 galleon per dozen flowers planted positive externality. So that puts our marginal social benefit at a vertical intercept of 110. And then we have this nice dashed line, which represents the marginal social benefit curve. And here, all we need to do is solve for the socially efficient quantity, the point where the social planner would pick. And this gives us so we have our Q star down here. which denotes the quantity that the social planner would pick, which is where the marginal social benefit is equal to the marginal social cost. So this is social. This happens where the marginal social benefit is equal to the marginal social cost. And the intuition here is like, if we were to add one more, so we went one past Q star, we would introduce more costs than there would be benefits to society. The next unit, the cost represented by the supply curve, would be above the benefits, which are represented by the marginal social benefit curve. So we don't want to produce more than this, and we also don't want to produce less than this. Because if we produce less than this, the benefits would outweigh the costs of increasing by 1. And so we would want to do that. Okay, so that's the intuition here. Now we want to solve for this thing. The marginal social benefit is the sum of the demand curve and the externality. So we have 100 minus 1/2 Q plus 10, which is our externality. And then we add it, we set it equal to the supply curve. And that gives us effectively this intersection. So that's just Q. Nice. And then from here, we just solve. So this gives us 110 is equal to 3 over 2Q. And then we denote this with a star because it's the socially efficient. So this is 220 over 3. Nice. So this thing, 220 over 3. Now, we want to find the deadweight loss. The first thing to do when we approach these problems is to think about the area. So where on this curve is deadweight loss, and how do we find it? The first way to, the first step in finding deadweight loss in these types of problems is to think about the difference between where we are, which is Q hat, and where we want to be, which is Q star. Society would wish to be here. Markets don't get us here, they get us here. And so the area of the deadweight loss will always be above this interval. So then we think about the extra benefits that we would get if we were to produce a little bit more. So we know that the costs are represented by this thing, and we know the benefits are represented by this benefit curve. So our deadweight loss is going to be this area. Deadweight loss, and it's always going to be between the marginal social benefit and marginal social cost. Okay, nice. So this is the deadweight loss, and we're asked to calculate it. So to do this, as always, this is a triangle, and it has a height of the difference between these two curves. That's just given to us by 10 galleons. So the height is 10. The base is the difference between this quantity and this quantity. So that's 220 over 3 minus 200 over 3. And then we just multiply this by 1/2. So this is 5 times 20 over 3, which comes out to be 100 over 3. Nice. So there's our deadweight loss. Very nice. So the next part of this vignette is to think about how we might fix the problem. So we've been hired by the Ministry of Magic, which, hires a lot of economists, it turns out. And they're thinking about how to fix this problem. It's like, okay, we know this problem exists. We're not producing enough. We would wish to produce more flowers. Flowers around the neighborhood would be very nice. So what we're going to do is try to think about ways of solving this problem. So, and the core problem is that we're not producing at Q star. We're producing too little. So we'll just set this up as a graph again. We have quantity on the horizontal, price on the vertical. We have our demand curve, our supply curve, our marginal social benefit curve. And we want to produce here, but we're producing here. So the core problem is that we're not producing enough. A tax, which is a type of policy we can implement in some examples, in some environments, would reduce the quantity. So a tax is actually sort of the wrong direction to go. Instead, what we would want is like an opposite of a tax, what we call a subsidy. So let's impose a subsidy. And when we're imposing a subsidy, the basic idea is that instead of taking money away when, it's like I as a buyer have to pay the seller and I pay the government. When we're working with a subsidy, what we're doing is just the opposite. It's like the government actually gives money during an exchange. So the price for the seller is actually greater than the price for the buyer by the amount of the subsidy. And just like in a